Hi, everyone. Welcome to GIA Knowledge Sessions. If you've been with us before, welcome back. If not, then GIA Knowledge Sessions is a series of talks and seminars about gemology, fueled by our decades of research here at GIA. And at GIA, we're very lucky to be able to spend our time every day in and day out, studying gemstones, learning about gemstones, investigating their mysteries and their secrets. And as an educational institution, it's part of our mission to share everything we learn with you. I'm excited to kick things off today. My name is Aaron Palke. I'm a gemstone researcher here at GIA, and I'm joined by Dr. Chenhui Zhao, GIA's Senior Manager of Research for Pearls. Feel free to ask questions as we go, because I'll be keeping track of all those questions, and at the end of the talk, Dr. Chenhui Zhao will have some time to have a Q&A session where he'll be able to answer some of your questions. With that, I'm going to pass it over to you, Chenhui.
Thank you, Aaron, and hello, everyone. Welcome to today's session. So over the course of last 15 months, since last April, GIA researchers have delivered close to 100 webinars covering a wide range of topics. Those included diamonds, color stones, pearls, field gemology, geology, jewelry history. So as for today, as you can see from the title, I'm going to discuss and group a number of gemstones that are particularly from the ocean, from the sea. And this is a group of unique type of gem materials because they are biogenic materials, which means they come from a living organism or at least once living organism, as opposed to most of the gemstones that are inorganic minerals. So they possess some interesting and unique characteristics. And I hope that some of the information covered today will be interesting and informative to you as well. All right, so humans have been interacting with the ocean since the beginning of our history, especially for humans living near the coast regions. The material that I'm going to talk about today, those materials were probably also one of the earliest type of gemstones used by humans. This is no surprising because these materials are easy to get access to, easy to be obtained, and they do not require advanced technology in order to process them, separate them, or facet them into beautiful gems. They are intrinsically having the gem property, the beauty of the gemstone. So for today, I'm going to discuss mainly three types of gem materials here, which is listed here: shells, which is also called mother of pearls. Then we're going to talk about pearls, which is one of the most important type of gem material from the ocean by value and by volume. And then we're going to talk about corals. Coral is also one of the most important type of gemstones from the sea. Historically speaking, it's very important. And there are a few other materials that I'm going to cover, which I believe that they are from the sea. So I'll be talking about them at the end of this presentation. So here, you can see some of the examples of such materials being used in ancient artifacts and jewelries, such as this shell amulet. It's made in ancient Mesopotamia region in the form of a bowl, and here is a perforation here. So people have been wearing them since the ancient time, and this is a necklace containing shell discs, some other kind of stones, and the mammal tools. This piece was from the Neolithic period, approximately 10,000 years old. These later day jewelries are from the Roman Empire, approximately 2,000 years old. This is a pair of earrings with gold and the natural pearls. This is a pearl and emerald bangle, and this one is a gold pendant with coral. So as you can see, such materials have been used since antiquity. And when we are saying these materials are probably one of the earliest type of gemstone used by humans, we do have some evidence. So I'm showing you two studies of the early shells used for human adornment. On the left-hand side is a study by a group of scientists. These gastropod shells were found in a cave in South Africa called Blombus Cave. And these shells, according to the scientist study, according to the contextual information, the morphometrics study, and the use wear analysis, these perforated shells are not just ordinary shells being used by early humans for any other practical reasons, but they are particularly used for personal ornament. So basically means these shells were used as gemstone material. So shells can be used by early humans for many different reasons. Shells are really useful. I mean, people can collect food from the shell, then use the shell and shape them into different tools like bowls, like scrapers, like blades, even fish hooks can be made from the shell. But these shells in particular are used for personal ornamental use. And these shells were dated to 75,000 years ago. That was pretty old. However, another study from a different group of scientists found some bivalve shells in caves in Israel. And those shells were even older. Some of the shells were from caves approximately 160,000 years old, and some shells were from 120,000 years old. The ones from the 160,000 years old cave, those shells did not contain any perforation, no sign of use as personal decoration. However, the shells found in around 120,000 years ago, those shells contain perforation and also signs of use as a personal adornment. So scientists conclude that sometime between 120,000 and 160,000 years old, the humans started to learn or use shells as gem material. So those are two evidences showing you that humans have been long using shells or similar materials from the ocean as gem material. So this is also no surprising because these materials, when you open a shell, they instantly become a gemstone. Why? Because the inside of the shell, a nacreous shell here, have very high luster and a beautiful iridescence. This iridescence is caused by light interacting with the nacre structure, the mother of pearl structure that's inside of the shell. Here is a diagram showing you what is the structure of the nacre looks like. So on the outer region, we have the tough outer skin of the shell called periostracum. It's composed of a polymer called chitin and also a layer of calcium carbonate, usually made of calcite. Under this outer skin, there is the actual mother of pearl region. These are the layer of calcium carbonate, usually in the form of aragonite. And those aragonites are stacked in a brick and a mortar kind of formation, layer by layer. And this layer structure is the cause of the iridescence, because when lights hits on these surfaces, and these layers are really thin, approximately 300 to 500 nanometer thickness. So when the light's interacting with different layers and being diffracted in different ways, you will see this spectrum of color showing on top of the pearl, on top of the shell. Here is further inside is the mantle tissue. Mantle tissue is responsible for producing the calcium carbonate that's also responsible for the growth of the shell. Now, a side note is when we are talking about shells being used in the jewelry, we're talking about mollusk species. The most common mollusks that we use the shell for jewelry purposes are from the gastropod and bivalves. Not all mollusks can be used as jewelry purposes. Some of the species from the Polyplacophora, even though they have shells like these plated shells, we really don't use them as jewelry purposes. And some of the animals from cephalopods like squid and octopus, they don't even have an external shell to be used. However, there is one type of gem material, one type of species which is already extinct. It comes from cephalopod, and it is also a very special type of gem material. I'm going to talk about this a little bit later in the talk. I'll keep a little bit secret here. I think that some of you may already guessed what type of material it is. I'll come back to it. So here some more examples of the shells used in the jewelry. Some are antiques, some are modern designs. So these are the gastropod shells being decorated by different type of gemstones. Shells were quite popular during the Victorian era, used to make cameos. Because of their abundance, shells can be made into different relatively inexpensive jewelries, and these shells looks like they are being dyed. These are a group of very unique and characteristic type of shells. I think some of you can easily recognize it. This is from abalone shells. Abalone shells are so unique and characteristic, you can easily tell because they have such strong iridescence, very beautiful, strong blue, yellow, green, sometimes pink and red, multiple color on their surface. So they are commonly used to make beautiful gem jewelries. These are not pearls. These materials are shell beads coated with certain polymers to make them look like pearls. So these are pearl imitations. So shell beads are commonly used to make shell imitations to make look like South Sea pearls, South Sea white, yellow, golden, and Tahitian pearls. All right, so shells until today, they are still quite commonly being used for jewelry purposes in the jewelry industry. You can see them in many different brands, and I'm sure that you have seen many of the designers on using shells as well. So since shell is called mother of pearl, we could imagine that pearl also have very similar chemical mineral composition as well as characteristics as their host shells, which is true. Most of the pearls are made of calcium carbonate in the form of aragonite, and nacreous pearls are usually having this concentric layer structure similar to the shells, and so that's why they also can have the iridescence effect by interacting with the light. This is a beautiful Tahitian pearl sitting on top of a Pinctada margaritifera shell, which is the host shell. And I can also imagine that when early humans open the shells for food, they will find pearls, and those pearls can be used as gem materials. Unfortunately, because pearls are much rarer and it's much harder to preserve pearls, so there are not a lot of evidences of old pearls being used by humans. The earliest I can find is this pearl, which is about 7,500 years old. This pearl was found near the coast of Arabian Gulf. There are a few burial sites, and people found up to about 100 pearls in those cemeteries. These pearls are decorated around the deceased and in the cemetery. So which means at that time, people already highly value and treasure pearls. Another interesting point from the article here is that when you are thinking about natural pearls, they are usually most likely from Baroque-shaped pearls. Round and near-round pearls are very rare. However, in these cemetery, in these burial sites, people found that most of the pearls are round and near-round. That's probably the earliest pearl grading or pearl selection process done by humans, because humans intentionally pick the high quality round, near round pearls to honor the deceased person. So this is something that very interesting to note. So today I'm going to quickly go through some of the major type of saltwater pearls from the ocean. I'm going to skip the freshwater pearl because we're talking about gemstones from the sea. In this first chart, it shows you most of the nacreous pearl species. They are under the bivalve class, under different two genus, which is Pinctada and Pteria. We have the Pinctada madallentica, which is the Panama pearl oyster. We have Pintada margaritifera, which is responsible for producing the Tahitian pearl. Here, the Pintada maxima, which is responsible for produce the South Sea cultured pearl. Pintada focata produces the Akoya cultured pearls. Pintada maculata is called PP pearls. And Pteria sterna, which is also called rainbow-lipped pearl oyster, and the Pteria penguin. Okay, these are common type of nacreous pearl producing species. For Pintada focata, there are a few related species, which is Pintada martensi, Pintada radiata, Pintada imbricata. These species are related and spread out in different regions of the world. So scientists sometimes group them together and call them Akoya complex. This is second chart is showing you most of the non-nacreous pearls that be produced by different species of the mollusk. So under bivalve class, we have the spondylus pearls. We have the Pinidae family producing pen pearls. Tridacninae subfamily, we have these Tridacna gigas, giant clam pearls. And then we have the Mercenaria, the northern quahog pearls. And finally, we have the scallop pearls. Under the gastropod, we have the cassis pearls, the horse conch pearls, the abalone pearls. Abalone pearl is the only nacreous pearl among all these ones. And then we have the mellow and the famous queen conch. The queen conch pearl have different scientific names. It used to be called Strombus gigas. Now we call it Lobatus gigas, although recently I found some articles mentioning about they have been changed to Aliga gigas, but I'm not sure yet. But you need to remember that all these means the same thing. They are talking about the queen conch the species. When we're talking about pearls, we're not really mentioning anything about the species from the Ostridae family. Sometimes we call pearl oyster, but they are not true oysters. The true oyster are the edible oysters from this family. And although they can produce some pearls like these two articles showed, we have one article here published by GI staff. A few years ago, a client went to a restaurant having the oyster and found a 15.53 carat pearls from the Ostridae family. This is an example of such species, but these are not pearls. These are fashioned shells made using these shells to imitate pearls. And you can actually read both of them on GNG. We wrote lab notes on these things. So Ostridae family, they are not a major source of natural pearls. So we did not include it in the chart. Now, historically speaking, the most significant important type of pearl oyster is the Pintada radiata, which is commonly found in the Gulf region, the Arabian Gulf region, and also in the Indian Ocean, the Gulf of Mannar between India and Sri Lanka. Historically, it is a very important source of natural pearls, highly valued. People sometimes call them different names. Oriental pearls, Gulf pearls, Basra pearls, they mean the same thing. And Basra is the city in the current day Iraq. It's probably in where the trade routes that go through. So that's why people call it Basra pearls. And even nowadays, there are a lot of trading activities on natural pearls in the region in Middle East and India. Although there are also some small scale culturing activity on Pintada radiata in the Middle East, but majority of the pearls are still natural pearls found in that region. Here you are seeing three major type of saltwater cultured pearls. First, we have the Pintada focata, the Akoya cultured pearls, which was invented by Mikimoto during the late 19th century and early 20th century. They can produce these high luster, very nice looking pearls. And then we have the Pintada maxima, producing these beautiful white South Sea and golden pearls. And Pinctada maxima is the largest type of Pinctada species that can produce pearls. And then we have the Tahitian pearls from Pinctada margaritifera. These pearls tend to have dark colors with beautiful overtones like pink, green, blue, and even orient. And these pearls are being produced in the Indo-Pacific Oceans in countries like French Polynesia, Fiji Island, Micronesia, and so on and so forth. So these three type of cultured pearls are the major type of saltwater cultured pearls in the market nowadays. Here are a few others, Pinctada madlentica, which is the Panama pearl oyster. They usually produce dark colored pearls. They are commonly found in Central America, the Gulf of Mexico, the Baja California region. They are usually natural pearls. Then we have the PP pearls from the Indo-Pacific region. This is the smallest type of Pinctada species that can commonly produce pearls. They can have different colors, but the most characteristic type is the golden small PP pearls. Peteria pearls, Peteria sterna, which is found in Baja California, the Gulf of California. They usually produce darker colored pearls, natural pearls, but there's also culturing activity in Mexico, which produce cultured Peteria sterna pearls. Because they are called rainbow-lipped pearl oyster, so their lip having very high iridescence. So that's why their pearls also can show very nice and high iridescence, very colorful pearls. Peteria penguin is found in Indo-Pacific. They tend to have a lighter color than the Peteria sterna. Their shell look like a foot of a penguin, so that's why they're called Peteria penguin. Now let's move on to some of the non-nacreous pearls here. Pen pearls from Atrina and the Pina species. This type of pearl is usually made of calcite, not aragonite. So the surface pattern, surface structure is different for these type of pearls. They usually have this kind of cellular pseudo-hexagonal kind of pattern, and this is very unique to this type of pearl. Pearls from the Tridacninae clan family, which contain all these different species. The most famous one is the Tridacna gigas. It can be really huge and big, more than 100 kilograms in weight. And their shell look like this. They have the folds or fluted kind of shell. And when they die, they become white, but they actually used to be very colorful. They can produce really nice white colored non-nacreous pearls with beautiful flame structures. Pearls from the northern Quahoe clan, more particularly from Massonaria. These type of species commonly found in the east coast of Atlantic Ocean, from east coast of Canada to New England to Long Island to New Jersey. So these clams are commonly used to make different type of clam chowders, like New England clam chowders, Manhattan clam chowders. So you might have heard some stories that people finding natural pearls when they are eating clam chowders, and this is usually from this species. And these pearls are usually in purplish color, similar to the inside of their shell. And they are usually button shaped, but they could have different shapes as well. Some of them could be really light in color. They are porcelaneous, but they usually lack the typical flame structures seen in other type of porcelaneous pearls. Scallop pearls. Scallop is also beautiful animals with very pretty colorful mantles. So they can produce pearls similar to the color of their shells. Most commonly the purplish ones, but their color are not even usually. Scallop pearls is also similar to pen pearls. They are made of calcite, not aragonite. So their surface is also in the mosaic kind of cellular patterns, not the porcelaneous ones, not the nacreous layer by layer structures. Spondylus pearls, this is interesting looking animals. Their shell is very spiny. So they can produce pearls, non-nacreous pearls, similar to the color of their host shell. And they can have really beautiful flame structures as well. These flame structures have a characteristic bluish tint sometimes, and we have been receiving some of these pearls from our US labs because they are commonly found in the Baja California, the Gulf regions. So these pearls are very characteristic as well. The famous conch pearls are being found in the Caribbean region near the coast of Florida. They can form different colored pearls like white, yellowish, orange, brownish, but the most common, the most valuable and sought after kind of color is the pink to red colors. They also can exhibit very nice flame structures of different types. And this flame structure usually also is a value added traits for these pearls. Similar to conch pearls, mallow pearls also show beautiful flame structures. They are large sea snails, very large. Some of the pearls produced could be also very large. We have been receiving a lot of large mallow pearls. One of the largest is probably more than 250 carat. They can exhibit very nice flame structures. Some of them look like Christmas trees here. Under the scanning electron microscope, for those non-nacreous pearls, you are seeing this different aragonite arrangement than the nacreous pearls. Nacreous pearls, you have the brick and mortar kind of concentric layers, but for non-nacreous pearls like mallow and conch, you will see these sheets of aragonite being arranged in a crisscross pattern. And this pattern is probably the reason why you are seeing the flame structure, because when light hitting on the surface, you have this light and the dark contrast. And this contrast is giving you these flame structures. Cassis pearls, cassis can be found all over the world. They can produce orange, yellowish colored pearls with nice, beautiful flame as well. But on the other hand, it is a little bit difficult to separate certain pearls in order to separate the species of these pearls between cassis, between mallow, between conch. Sometimes there's a little bit of difficulty and challenge. However, you can look at the flame pattern. Sometimes the flame pattern is slightly different for cassis pearls. And the internal structures, some of them also show a little bit differences. So even though there's a challenge, we are trying to continue to study these different type of pearls in order to separate them in the lab. Abalone pearls, similar to their shells, can exhibit very beautiful iridescence. Strong green, blue, yellow, and a pink multicolored appearance. Some of them can show really characteristic shape like this horn shape, or what we call shark tooth shape. They can be really large as well. Abalone shells can also be used to make mabe pearls. Mabe is a special product from the pearl industry. They are shell blisters because people put a half dome shell, stick to the shell, and then a thin layer of nacre will be deposited on top of the shell. And after a while, people cut it out, take the bead out, fill it, and put the shell back in. And this kind of product will form. This kind of practice is easier and it takes less time. So sometimes people tend to make mabe pearls instead of making a whole pearl. Finally, we have the horse conch pearl. Horse conch is also from the Caribbean Sea, the coast of Florida. And these beautiful animals can produce very nice, dark colored, usually reddish, strong orange reddish pearls, sometimes brownish. They also can exhibit very nice flame structures. This is there are two pearls that's submitted to our Hong Kong lab, and we wrote a lab note a few years ago. Here is just another summary of different type of saltwater pearls. human uses from the ocean. And due to the time limitation, I'm not able to go into details and also not able to cover some of the freshwater pearls. Last year, Nick Sturman from GIA presented a very nice topic, Fascinating World of Pearls and Shells, and you can actually watch it on our YouTube. Basically, all our webinars from last year, you can find them in our website, and also link to the YouTube is provided. All right, so let's move to our next topic, which is another very important gemstone from the sea, which is coral. Coral is a name used to describe tiny marine polyps. These are spineless animals with a soft body here and also a hard protective exoskeleton composed of calcium carbonate. This skeleton part is the part where human uses for jewelry purposes. Okay, coral can produce, there are many different kind of corals, can have different colors, white, cream, yellowish, golden, blue, black, but the most important and the most sought after valuable type is the one with a variety of pink, orange, and the red colors. And coral can be made into beads, or because of their free form shape, you can make them as decorative objects. So humans have been using corals since antiquity as well. In this article, you will see that there is already trade or exchange in the Alpine region on the Mediterranean corals during the late Neolithic and the Copper Age. And this one is a red coral necklace found next to the remains of a person buried in the mines of Gava in Spain. And this piece was collected by Museum of Catalonia in Spain. So that's about 8,000 years old coral necklace. So as I mentioned, there are many different type of coral species, more than 5,000 species. According to CIBJO, not all of them are considered as precious corals. As a matter of fact, only a few species under the Corallidae family are considered as precious coral. Precious coral means that the coral used in the jewelry industry, not necessarily including the decorative objects. So some of the corals that you might have heard, spongy corals, Alaskan gold coral, bamboo coral, blue coral, those are called common corals. They might be used for decorative purposes. They might be used by humans for other purposes like using in the aquariums, fish tanks, and they can be also treated to imitate precious corals. And all these corals are under the Anthozoa class and the Octocorallia subclass. Octocorallia means their branches are 8-fold symmetry. And then we have the Hexocorallia subclass containing a few other common corals like the black corals, the staghorn corals, finger corals, and Hawaiian gold coral. And all these are not considered as precious coral. So here is just another table showing you different type of precious corals, but in the trade, people usually refer to trade names instead of coral species. So you might have heard different trade names like Akamoro and Oxoblood. These are from this species called Coralline japonicum, and then this is from the Japanese water. And then we have other species from different regions of the world, Japan, Taiwanese water, the Vietnam, and the Hainan water. We have the famous angel skin, and then you have the corals found in Hawaii and the Midway regions. But among all these precious corals, the most famous and historically important type is the Sardinian or Mediterranean coral from Corallian rubrum. And this is also the only source of coral in ancient world. Okay, all these others are found in the recent centuries, but this one is found long time ago. So there is a very extensive trade routes in ancient world from Mediterranean Sea to Africa, to Europe, to Middle East, to India, to China for the coral trades. This is just another map showing you where those precious corals are being found. Here we have the Japan and Taiwanese waters. Then we have the Red Sea, the Mediterranean Sea, the Bay of Biscay near the coast of Europe, and then the Canary Islands near the coast of Africa. Here we have the Hawaiian and the Midway region. Now you have heard there's a lot of talk about conservation concern about corals. So even though precious corals are only a small number of species among all different type of corals, countries around the world, especially those producing precious corals, they do have some sort of regulations to monitor and control how you can collect corals and how much coral you can collect. So I will be talking about conservation at the end of this today's talk, but just to let you know that these are some of the major area or source of precious corals. So corals, even though they are made of calcium carbonate, usually in the form of calcite, sometimes aragonite, similar to pearls and shells, but they can easily be differentiated from pearls and shells. Coral have those very unique channels, which is used by polyps to transport nutrients. So even though if they are being shaped into beads, you can see some different surface textures like these striations. And sometimes they have a ribbed and pitted scalloped surface. You can easily identify them. As I mentioned, some corals can be treated to imitate precious coral. So for treatment, they usually being bleached first and then dyed red into imitate precious corals. And here you have a completely dyed coral that's trying to imitate precious coral. And this is not even a coral, it's an imitation. It's a marble being dyed, and you can see the color concentration to imitate precious corals. So how do you tell if a coral have a natural color or not? In the lab, we can use Raman spectroscopy because coral can contain natural pigment related peaks, which you can find in 1100 and the 1500 wave numbers under the Raman. These are natural polynic peaks, similar to some of the pigments found in natural pearls, like conch pearls. So we have an article a few years ago talking about this coral identification. Finally, a few images of coral jewelries. Some of them are really interesting designing, like this strawberry jewelries from Tiffany. And then we have this fish and the coral designing, because coral have free form, so you can really make the very interesting designs. Coral can be also used to make cameos, which was popular during Victorian era. This is an interesting object we call it court necklace from Qing Dynasty in China. And those necklaces are worn by higher officials and also royal families to show their social status and wealth. And they have different type of stones being used, and coral is usually one of the stones. This piece from Met Museum, these are supposed to be corals, but they are imitation corals. So you can see that how precious and how rare corals are, even in those expensive and high status necklace, the people have to use imitations. This is another very interesting gemstone, which is not coral, but it's actually pearl, Akoya pearl. These are Akoya pearls cultured using coral bead. Okay, so instead of using a white shell bead to culture pearls, some people have found to use coral bead, and the end product have a very attractive pink color, and the pink color is coming from the coral. We wrote a lab note a few years ago. Our Japanese staffs in Japan wrote a lab note and to describe this group of unique products. I think it's called Sengo pearls in the trade. All right, so we are basically finished talking about the major three types of gemstones from the sea. For the remaining time, I'll go through a few gemstones that I consider as gemstone from the sea. I'm not sure if I missed anything, if you have any thing else that you can thought of, feel free to submit through the Q&A session. Let me know. I would be interested to know. The first one is a little bit surprising though, Baltic amber. Baltic amber is a type of amber, and the amber is a fossilized tree resin that has been appreciated for its beauty, for its color, the organic warmth, natural beauty since the Neolithic time. And the Baltic Sea region is the region where the largest deposit of ambers are found, especially in this Kaliningrad area. So you might ask, these are tree resins, so why do we consider them as a gemstone from the sea? Well, they were formed more than 40 million years ago. So because of the geological change, the marine transgression, so the sea level rose and flooded some of the areas. The forests. So nowadays, you can actually find these ambers at the bottom of the ocean on the seafloor. So you can actually fish for the amber. Okay, and sometimes because of the waves and the storms, can bring the amber to the shore. So people can also collect amber near the coast as well. Ambers can have different colors, transparencies, and they can be made into gemstones and fit for jewelries. But amber also contain interesting material because of their formation. They can sometimes capture beautiful insects and plants, prehistorical species, extinct species, which are valuable for scientists to study, for biologists to study them. So Baltic ambers, not only for gemstone, but can have a lot of other valuable scientific uses. Now, an opposite of Baltic amber, and also, do you remember that I mentioned about cephalopod in the beginning of the talk? This is what I'm talking about, ammonite. Ammonite is a group of extinct marine animals. They are more related to squid and octopus than the nautilus, although their shell looks like nautilus shells. So this is a type of cephalopod which can show because they are fossilized, they show very nice, beautiful iridescence on the shell and can be turned into gemstones. And we call the animal ammonite, and we call the gemstone ammolite. So that's the two different names. You might see them used in different ways. They can be used in different jewelries, but why do I say it's the opposite of Baltic amber? Because Baltic amber was formed on the land, but you can find them in the sea. Ammolite, they were formed in the ocean, but now you can only find them through mining. This is because that ammonites are commonly formed in the western interior seaway in North America millions of years ago. This area, Canada and the US, between the border, Alberta and the Montana region, through the Rocky Mountain, there's something called Bear Paw Formation. These are the places you can find ammonite nowadays, but millions of years ago, these places are seas. Okay, these are interior seaway. So that's why I said it's opposite. Now you can find them on land. Next, which another material commonly used in the history, which is from the sea, is tortoise shell. Tortoise shell is a material that produced from the shells of the larger species of tortoise and turtles. One particular species that commonly used is hawksbill sea turtle. Their shell have beautiful patterns that people have treasured. However, just for your information, this species is critically endangered nowadays, so you are not supposed to trade them. But you can find them in some antique pieces. Historically, it has been widely used to make different objects, such as combs, such as boxes or inlays of furnitures, the frames of spectacles, even guitar picks. You can make a lot of stuff using tortoise shells. These are some examples of jewelries made by tortoise shell. We have the comb decorated with corals. We have a nice bangle, a carved bangle made from the tortoise shell. And this is a piece from Met Museum, necklace and pendant. Once again, this species is currently critically endangered, so any trade is banned. All right, finally, if I think a little bit harder, if you consider anything that's used for jewelry would be considered as a gemstone, then these are the materials that many indigenous people of different parts of the world have been used for making decorations. So we have shark tooth. Shark tooth can be used and incorporated into jewelries. Shark tooth was actually commonly used in Hawaii by the native people there to make weapons, blades, spears, things like that. Fish vertebrae, which is fish bones. Fish vertebrae can also be used to make necklaces like this. These vertebrae was found in cemeteries and people put them together as a necklace. If you search on eBay or Etsy for fish vertebrae, fish bone necklace, you might still see some very interesting design, modern day made jewelries using fish vertebrae. And this is a very interesting object, which is found in, which is collected in a museum in New Zealand, but this one was actually from Fiji. This necklace was worn by the Fiji chief using sperm whale tooth or ivory, we call it. So these are actually intentionally made into this different lens designs to show the wealth, the power, the social status of the chief. So if we consider these materials to be used as jewelries, we can also consider them as gem materials. So a lot of creative designs and ideas coming from human beings. Finally, as I mentioned, we're going to talk about conservation because most of the items we're talking about today was from living organism, except fossilized amber and also ammonite. The other type of material are from living organisms. So you have to be aware of the government restrictions. There is something called CITES, Convention on International Trade in Endangered Species of Wild Fauna and Flora. So this is an international treaty signed by most of the countries in the world trying to protect endangered vulnerable species. And there are 3 different levels. We have the Appendix 1, which is the highest level of protection under CITES to conserve species threatened with extinction. Commercial trade is prohibited. Then we have the Appendix 2, commercial trade is allowed, provided certain procedures are followed to ensure it is legal and sustainable to conserve species vulnerable to overexploitation. Then we have the Appendix 3, which is less vulnerable, but some countries consider it as vulnerable and has requested assistance to help regulate the trade. So if you know what kind of material and species you are talking about and you are dealing with, you can always go to their website, search for the species name and see whether any of them are listed in CITES. And in the US, you can also check the US Fish and Wildlife Service to see more information about endangered animals and the species. As far as I know, there are several species of shells and are under the Appendix 2, and some of the precious corals are under Appendix 3. All right, so this is pretty much it for my today's talk. I'm leaving this last slide here for you to review. We're talking about biogenic gemstones from the sea today, but there are a lot more activities happening in the sea, and there are a lot more things we can obtain and gemstones that we can obtain from the seafloor, such as diamond mining in the sea. diamond mining, marine minings of diamond has been around for a long time. We have an article here on GNG talking about it in 1991. Nowadays, this picture is from Debmarine, which is from De Beer and Namibia, and they use very advanced technologies to mine diamonds from the ocean. But this is not the focus of today's talk, and I'm just leaving here for your interest. So this is it for today's talk, and I'm ready to answer some of your questions now. Thank you for listening.
Thanks, Chunwei. It was a really great presentation. And we have a lot of good questions as well. So let's see. The first question, which I thought was quite interesting, is it possible to identify all sea pearls, corals, etc., all of the kind of gem material you talked about coming from the sea? Is it possible to identify them by their DNA?
That's a very good question. First of all, routine laboratory examinations does not require DNA. For pearls, particularly some of the pearls are so characteristic, so we can easily identify them through routine techniques, the gemological methods and advanced instrumental methods. In most cases, coral may be a little bit more difficult, but DNA can certainly help. You have probably heard a few DNA studies of corals and pearls in the literature. We have also been doing some of the works on pearls. So as far as I know, DNA exists in pearls and corals. And you can use DNA as a supporting way of identify the species of such materials. But in most cases, we can easily identify whether a pearl and a coral is natural or cultured or synthetic or imitation, and whether the color is natural or not. These type of things are easily done in the lab. Species identification is a little bit trickier, but as I said, some of them can be done using the traditional methods, but DNA can always help. And we are continuing to investigate in such method at GIA in the future, and hopefully that this can be used in a more regular ways in the future.
Thanks, Chunwei. So another question from Gabriella Farfan. She's asked, she's noticed that the pink color of conch shells often bleaches in the sun. And she's asking, is the pink color in conch pearls stable or light sensitive?
That's a great question. So normally speaking, conch pearls, they are relatively stable, but they are actually vulnerable to certain lights, such as shortwave, UV light, and also X-rays. X-ray is really detrimental to the color of the conch pearls. If you put a conch pearl in the X-ray machine for a relatively long time, not even maybe more than a few minutes, it may start to fade. The color can start to change. Shortwave UV can have the similar effect, but maybe it takes longer for them to fade. So it makes sense that if you put a conch shell under the sun for a long time, it can fade as well. Usually conch pearls, under normal condition, it shouldn't change. It's pretty stable, and you should be comfortably wear it from time to time. I don't really see a problem, but it does can change under prolonged exposure under certain light.
All right. Another question, which I think is maybe sort of following up on the first one about advanced testing. Someone asked, Tanya Sadao asked, is it possible to carbon date pearls?
Yes, carbon date can be used. We actually have done that. So we have an article about the Columbian era natural pearls from 500 years ago. So carbon date can help with pearl identification as well. Sometimes a pearl have very challenging internal structures, but it looks old. We might use carbon date to help with the identification. If it's old enough, we can consider it as a natural pearl. And also carbon date can help with the provenance of historically important pearls as well. Carbon date can only go up to 50,000 years or so. So older than that, we may not be able to use that method. But in general speaking, carbon date is currently well studied on pearls. You might have seen a lot of articles about them. So we actually have the ability to help carbon date the pearls if it's necessary, if it's historically important for you. In the lab, so we will help to collaborate and cooperate with you.
All right. And another question, how common are treatments of uncommon natural pearls? And I think they mean sort of like the non-aqueous pearls that you're talking about, the conch pearls and Malo pearls and that sort of thing. Do people ever treat those types of pearls?
Not very common. So far, most of the non-nacreous pearls, conch, Malo, abalone, they actually are pretty natural, and people rarely treat them. However, I just want to say more recently, our Bangkok lab and also in New York lab, we have seen some non-nacreous pearls being dyed. It's dyed to pink. It's probably from Tridacna species, but they are dyed. So we're going to write a lab note about it, and you will see it in the future GNG. But generally speaking, non-nacreous pearls are not being treated.
And actually, maybe a follow-up question from me is, it seems like non-nacreous pearls are getting quite popular these days. Has anybody tried farming non-nacreous pearls?
That's a very good question. So it's difficult to farm non-nacreous pearls because the species are very different than the usual pearl oysters. They easily die using the conventional techniques. As far as we know, there are a few farms trying to culture conch pearls, and then people have been there are some articles in GNG before. However, there's no commercial success yet, I suppose. There's no commercial volume of cultured conch pearls we have seen so far. For other type of non-nacreous pearls, it's also not really, as far as we know, there's not much culturing activity about them.
Okay. It'll be interesting to see how that progresses in the future. It does seem like those kind of non-nacreous pearls are getting more popular these days.
Yes.
Now, here's a question. I know you said you weren't going to talk much about freshwater pearls, but someone asked, how can we know if the pearls, or how can we differentiate between freshwater and saltwater pearls?
That's relatively easy. Freshwater and saltwater pearl contain different trace element concentrations, so we can examine their chemistry. Freshwater pearls commonly have higher concentration of manganese and a relatively lower amount of strontium, while the saltwater pearls usually have a very low or even no manganese, but relatively high amount of strontium. They also have different fluorescence properties. Under the X-ray, freshwater pearl tend to have strong fluorescence, while saltwater pearls, if it's not bee cultured, they usually do not have any fluorescence. Bee cultured pearl do have fluorescence because they use freshwater shell bead.
All right. Now, there's a lot of really great questions in here, Chun-Wei, but I think we've gone pretty far in this question and answer session, so I'm gonna call it quits for the question and answer, but we'll send these questions to you afterwards in case there's any good ones you'd like to respond to.
Sure.
And for the rest of you, again, Chun-Wei, thank you so much for your time and giving this talk. It was really informative. If the rest of you have any questions, please find us on Instagram, Facebook, LinkedIn, and Twitter, and please communicate with us there and ask your questions. Other than that, thank you for coming, and join us again next time. In 2 weeks, we'll have another webinar with Nathan Renfro and Nicole Aline. They're going to be talking about the journey of a gemstone through the identification laboratory here at GIA. That'll be on Thursday, July 22nd. So please join us then.